So, myself, Karthik, taking care of technical projects and processing. So today, I would like to give some good examples about what are the art and pain and everything. About to the annealed glass once it is produced, how we can use it, and what are all the limitations and what are all the possibilities. So all those things will mention. So I would like to add the specific 2 points about it when Sandeep was covering on float glass and water glass. I'll just add what are all the inspection method that is carried out inside the float glass. Next. So this is the basic outline of float glass. I will not take up much time on that. So once this process has been complete, the final before cutting next step. On this cutting area, like after cooling and cutting area, you will be having a specific online checking instruments, which will be 24 into 24 into 7 monitoring your thickness and sizes. What are all the things that is getting out of the furnaces? And additional to it, we are also measuring the continuous stress measurement for the anneal. That's why it is getting always in a good form of anneal, which is in a control way or in any other applications. So these are all the online measuring systems. And additional to it, there will be a vision-based system to inspect our spot faults, like whatever the manufacturing device. So whatever we are doing in a manufacturing way, that will be on 100%. There will be always a 99% of good, and 1% of somewhere it can go wrong. So that 1% also we can get it, and we can neglect in the lines. So this is the online measuring systems or inspection systems. And we also have a lab inspection system. So once we have taken any issues or defects that occurred in a sample, we'll be taking out and we'll be putting in a lab to ensure what is the size or how it is. Once we get the data, we'll also feed the data into our online system. So it is on both the sides. Like once we'll be checking with the lab, another one will be on the online. So this is the general criteria for whatever the thickness glasses that we are producing. So this is as per the EN 572 Part 2 of clear glass soda lime silicate glass manufacturing process. So for all nominal thickness, they have a different. So in nominal, if we take off 6 mm, it will be like plus or minus 0.2 mm of which the EN European standard states. But always our Saint-Gobain glasses will have a tolerance of minus 0.2. So it will, we have a very stringent limitations on a product that it should not later create any issues on products or in fittings. Next, please. And this is of your diagonal and sizes. So for our diagonals also same we have respective respective to thickness and jumbo sizes. And in between the sizes we have three criteria of 1500. In between some 1500 to 3000 and above 3000. So basically in floats we will have some three range categories of sizes. One is small split sizes, another one is a TRA sizes like roughly around some 2 cross 3 meter of glasses, and above 3 meter of glasses we call it as a jumbo glasses. So as per that the limitations has been given. So if you want to measure a glass in a diagonal way, the tolerance can be with the 3 mm of difference in a diagonal. So this will not go in a plus or minus, but in a mean way, like 1.5 or can go in that way. So this is on your diagonal, and this is for your spot falls. As I stated, they'll be taking a sample and putting it in the lab and inspecting the sample. So at that time, so that will be the criteria for putting the sample action. So that whatever it stays shows as a B is a sample, and A will be your screen, and C will be your observer. So at an angle, they'll be checking. So there are specific two angles. So one is for 40 and 45 degree, and another one is will be 45 and 50 degree. So both the angles they'll be keeping projection. The defect image will be kept on the screen. So by measuring that screen images, we'll be get to know what type or what size of defect that we are having, and whether we can pass it or we have to check it control over there itself. So this is one of the uh, spot faults mechanism inspection in the lab. So in that spot falls, whatever we have categorized is four categories. It depends upon the size of the defect. So class A defects says about 0.6 to 1.5 mm of defects. So B will be 1.5 to 3 and C will be 3 to 9 and D will be above 9. So whatever the glasses that we are producing in line will be almost below B. So that is what we are saying it as an acceptance criteria for manufacturing of soda lime silicate glasses. And this is with the float glass. Now we'll move with the coated glasses. So coated glasses are nothing but we have a two type of coating. One is a online coating and another one is a offline coating. So online coating glasses are done in a float process itself. So that products we call it as a soap products. And second one is the offline process for manufacturing of products. And that will be done through a magnetron sputtering process. So here also we have a two type of inspections. One is online, another one is offline. So whatever we have inspected on online float glass, the same will be taken care here also. So spot falls, product color inspection, and angle color inspection. So whatever the product that we are getting, like let's say if you are purchasing one product tray, and if you are going to purchase the same product a year or 6 year time, so still you can have a same color and same combination of. So that is because we are having a online checking system of color angle also. So this will give a good stabilization also throughout the manufacturing process. And for secondary, for coated products, we have a chemical analysis, the abrasion test for majors part. Why? Because once the coating has been done on a glass, we have to ensure that coating is not going out from the glass. So we are checking with the adhesion as well as the durability of that. So this chemical analysis and abrasion test comes under that. And once these glasses are taken, so all the glasses will not be only taken in the form of some products will be carried out in a lami or some products will be carried out in a process way like Hakan or HS. So we will also take a sample and we'll check it how that reacts. Is there any other difference between the prior sample to the what actual sample we have? So these tests are all carried out in the products. So this actually for coated products we have a standard of European standard EN 1096 part 1, which will be in the same way. So it has a two types of inspection. One, the observer will be in front of the glass, and in another criteria, the observer will be on the side of the screen itself. So you can see here. So this is a light source, and that is a product, and will be here in front of the screen itself. And in other criteria, you will be behind glass. So this is to one is to check on a reflection parameter, and another one is to check on transmission. So this is two. And while we are checking, we have a limitations on that. So these are all the limitations as per the EN 1096 part 1. So it majorly touches on a two part. One is of a spot faults, another one is clusters. So this is the major kind of effect you can expect in clusters. So spots and pinholes are they call it as a punctual or punctual defects, and the clusters are combined or group of defects in a specific area. So that they call it as a clusters. So here they will take it into a two parts. One is of main area and another one is of edge area. 10 to 50% of a green size they'll take it as the edge area. Remaining they consider the main area. So if you go for a spot pulse, let's say you have a defect of 3 mm, and if it is in the main area, it is not allowed. And if it is still in the edge area, it is not allowed. But if the size is more than 3, you can see 1 per bit square is limited. So these are all basic limitations that has been set by standard of EN 1096. So this is that spot fall inspection criteria, enhanced image. So you can see the light source and screen. So as I stated on the float glass EN 572 of part 2, the categories of defects will be categorized in A, B, C, and D. As same for coated glasses also, it has been stated in A, B, C, D, and every sizes and everything will remains the same. Now we'll move for crossing glasses. So till we have any, we can clarify on inspection methods of coated and float. Have any doubts? I know I'm like kind of bit running, but I don't want to miss any of those points. So I just want to inform. We'll just take with the it's 5 minutes. Yeah, 5 minutes. Then we'll close. Okay. Will they move? Yes. Just so 5 to 7 minutes, not more. Sure. Sir. So now, I think Sandeep would have taken, but again, I'll come up with the same question. Before getting into end customers or into a building, why we need a front glass to be there in site or in a building? Why? Safety. Yeah, this being already explained. Okay. Safety. Additional one. And I largest part. Also larger size of packages. Okay. Go forward. Come back. So this is some basic kind of thing we want to understand on the glasses is we will take it as an annealed glass and a fun glass. So in annealed glass, normally the strength will be like 45, and four times of it will be on your sunglasses. And there is a heat strengthened glass in between two annealed glass to different glass. So that will be in between two, like if it is like 120 or 100 or 90, 80 kind of Newton per ounce square will be there. So that will be on the strength part. And thermal, yes, up to like it can like in some of the recent videos or in online we could see guy was using a laptop and it could suddenly burst the tabletop glasses that they have kept. So that is also can withstand. Actually, your toughened glasses will go up to 50 degrees Celsius. It can withstand up to 50 degrees Celsius of temperature. And of course, yes, breaking pattern differs from annealed glass to toughened glass. The toughened glasses will have a small granular type of breakages, and annealed glass will have sharp, large breakages. And HS glass will also have a large sample kind of breakages, but whatever the breakages happens in the HS glass, heat strengthened glass, heat strengthened glass, it the cracks should always be going till the end. So whenever the glazing has been done, this cracks once it is produced formed to the edge, it will stick there itself. It will not fall. That's why we go in between two anneal and the we call it as a heat strengthened glass. So this is the general test that we'll be doing on processing during processing of for our HS glass. This applicable for a laminated glasses also. This they'll call it as a ball drop test. So this is nothing but they'll put a glass in. Okay, sir. I'll just give a beats. Yes. From whatever we have seen here, we will also see this all these things in the process place also in our third day. So this is the basic test. What we'll do is we'll have some 250 to 230 grams of steel ball, and we'll be placing a glass with some 3 mm from base. We'll have some front glass with a meter of 3 and at a meter of 6 and a meter of 12, depending upon the thickness and combination of glass. We'll drop the ball from the height. The thing is, the glass should not break on a front glass or hedges. Another thing, if you are keeping a laminated glass at the bottom and if you are going to drop a ball at 6 12, then the glass can break, but it should be. So this is the criteria for ball drop test on different and laminated. So this is the major processing under a processing plant. What all the process will be there? You can see there. So once the glass has been transported from our factory, it will be going into form of a storage, a warehouse. Then it will go for a thing for required size, whatever the sizes we need for a building. So that will be taken care in the cutting area. Once the cutting is complete, we'll be going for a grinding and polishing to get a smooth kind of edges or with grinded edges. Why we are doing is this because once the glass we are taking inside the furnace, it will have a thermal resistivity in the glass. So that will create the wear and tear at the edges. The simple property that we have, wherever there is a sheet edge, there will be wear and tear in the higher way than the so to reduce that inside the furnace, we are doing all the glasses with it. So this is the basic principle. Whatever the glass you want to do fine or HS, it should be rough grinded. And once that is done, this washing will be taken care to remove all the dust and dirt, whatever has been carried out before process. So this cutting, grinding, and washing, this three call it as a pre-processing or a pre-processing set. So once this pre-processing is completed, this will be going for a. So this pre-processing is a common set of process that will occur whenever the glass is moving for a processing. So once this pre-processing is completed, it will move for tempering or a tempering process. So in a tempering process also we have a bendable type of glasses which we can bend a glass. That is one of the process. And next to it we'll have a DGU glass. So DGU is a double glazed unit. So after a double glazed unit, you will have a lamination process. So finally, we'll see with the lamination process. So here in this pre-processing area, there are different combinations of skill. So only we want to keep this pre-processing as standard. And the pre-processing, once the pre-processing is completed, it can directly go to the tempering. Once the tempering is completed, either the glass directly go to a lami or either it can go to a double glazed or triple glazed, whatever the required. So this pre-processing will have always a shift. So sometimes requirement will be tough and lammy at each. So process will go like cleaning will be complete, then it will go for lammy, then it will go for a DGU, then your final raw materials. Right. So this is the basic cycle of a process. So for the same, you can see the basic machinery elements. So under the pre-processing, we have seen the three segments: cutting, seaming, and washing. So in cutting, we have two types of cutting. One is a automatic cutting, another one is a manual type of cutting. So now this manual type of cutting is not recommended. Why? Because we are always take part in a safety thing. Also, since it's a safety week, we need to just uh, rinse out of it. So handling a big pile of glasses or a single sheet is not an easy. It is a very big material. So we are completely eliminating a manual kind of process for a jumbo or bigger mixers. So all the facilities now it has been upgraded with the CNC cutting machine, which can have a tolerance of 1 mm plus or minus 1 mm, and it has a auto picker and auto loader with it. So your glass handling and your glass cutting will be without any difficulty. So it will be in a good quality that we are expecting. Thanks. So this is on the cutting wheel. So we have spoken about the cutting, but what type of cutting wheel has been used? So it will be like a tungsten carbide kind of cutting will be used. And for every thickness, there is a specified angle. So as you can see, this is the cutting wheel disc actually. This cutting wheel will be approximate in a dia of 2 mm. It will be very minute, 2 to 3 mm. It will be very minute. And this cutting wheel, this cutter edge will have an angle. Only that edge will be inclined in a angle, whatever it has been said. So for a specific of thickness, different wheel will be taken. And always while doing a cutting, there will be using an oil. It will be an vaporized oil to eliminate the sticking or any other fuzz in the rings. I think this can be the last thing. Pre-processing. So this is on a cutting. So this I have given some standard references of four different standard Australian, American, and Indian, and also European standards. So generally the standards, if let's say like European standard, if you taken or most of them we can see of plus or minus of zero point 0.2 on a cutting sizes. So the same as we have seen in the EN 572 part 2 of a three classes. So same will be carried out because in this EN standard, it has a good correlation from a float glass to coat product to a process to release also. So on the diagonal aspect, on a tolerance aspect, more or less it will be set. So this is on a length and width, as I stated, three different categories, and respect to thickness, the tolerance will be so everything will be. So this is on diagonal. Then second, we'll move with the seaming process. So seaming process will call it in a two way. One will be a grinding, the other one will be polishing. So in polishing also we have some 2 to 3 types of polishing. sea polishing, beveling, edging kind of polishing is also there, depending upon the requirement. So this polishing and everything will be on a indoor kind of activities like partitions and etc. Will be moving. For structural glazing regularly, we'll go for a plating. That will be more than enough. So once that is completed, we'll be moving for a washing. So on a washing process, nothing much. The glass will just flow in a roller continuous conveyor with a flush of water, a 6 to 8 bar pressure. So on the moving part of it, like what will be in a control with the pH, integrity, and temperature. So this will give a good clarity and cleanliness on a glass to remove the dust and etc. other foreign particles. So I think with this we'll wind up reprocessing. So tomorrow I'll continue with the tempering, heat strengthening, insulation, and lamination process.
So, well, the tempered glass cannot take the cutting and the drilling of it or the making of holes, right? Because any
No,
patch doors or any patch glazings,
no.
the
Why?
hole is done and then the patch size is done, then the tempering is done. Why is that? I mean,
Actually, what we are making is like if I explain the tempering process, that will give you a. I'll take this question.
yeah.
Hence tomorrow when I start, I'll be explaining it because I have a food selection. Apart from this, any other question on the pre-processing part or float or photo glass? So tomorrow we'll have a quiz. Okay. Before that, we'll come.
So I have the
Okay, thank
presentations
you.
with me.
So, yeah, tomorrow or